Reaction of chloride is water. Okay, here we go. Run through left to right, right? All of them. Okay, ladies and gentlemen, ionic chlorides. The ionic only 2. So what is the difference? Is there. All right, so here we go. Make it big one at a time, never mind. Now, ionic chloride, once again, they will always do what? They will always dissolve in water through ion dipole interactions. Where are we? We are in bonding, we're in energetics. Basic fundamentals. Why the ion dipole interaction? Simply because the dipole comes from the water, which is polar, and the ions come from your ions. And eventually they form your hydrated ions. So take a look at sodium chloride. First few marks. Sodium chloride has very low charge density. Okay, I'm running out of color, so I uncolor everything. So here we go. All right, sodium and chloride ions has very low charge density. So once again, what is charge density? Charge density is equals to charge over size. So let's just compare sodium ion versus the rest of the cation. All right, the charge is quite small, 1+. The size is quite big compared to the other ions along period 3. So therefore, this is small. Done. Bonding 101. Energetics 101, right? So because of its low charge density, all right, the sodium chloride itself, this salt, will therefore not what? Will not hydrolyze in water. What they do is they only dissolve in water to form a neutral solution of pH equals to 7. The equation that you want is this equation. Some people go and do this kind of mistake. Some weird acid-base reaction occurring here. Okay, they do some weird reaction mechanism, right? Once again, sodium chloride doesn't do this. They only dissolve in water to form pH 7. They don't hydrolyze. Now, what is this known as? Right? So if you take a look, what happened? Sodium chloride by right has what? By right has strong electrostatic forces, right? Ionic bonding. And the water come in. Water is here. Okay, whichever, one here, one there. So what does water do? Water is a polar molecule. It then forms this tube. Right, here's delta minus, by the way. Running out of colors. Let me just use spin. Delta minus, delta plus. This delta minus, this delta plus. Oh, I draw wrong way. Okay. So I just draw one. All right. I draw two. Just a moment. Okay, what is this? Opposite charge always attract. This is what we call your ion dipole interaction, which is very, very strong. Stronger than electrostatic force of attraction, and therefore it overcomes it. Okay, wrong way. Overcome this one, the electrostatic force of attraction. And if you look at it, this is what we call a hydrated ion. All this was since secondary 3. Yeah, I zoom. Very sensitive. So, ladies and gentlemen, hydrated ion, sodium, hydrated ion, chloride. Okay, so what is happening over here? What is this reaction called? This is called hydration, which forms your hydrated ion. Next, magnesium chloride. Our pH is not 7, it's 6.5 right now. Why? Magnesium chloride has the Mg2 plus has a higher charge density than sodium plus. So MgCl2, right, will do what? Okay, it will dissolve in water, and the hydrated ion will then undergo something else. It's called slight hydrolysis, which therefore form the slightly acidic solution of pH equals 6.5. What really happened here, if you look at it, is that the same thing happened like sodium chloride here. There are 2 steps. Each of them has a name. Once you get this, you're okay. The problem is in school, they read out this and then they never explain. And therefore, you also memorize it without understanding. It's hydration. Take a look. It makes sense. Magnesium chloride, put into water, you form this. So what happened is the same thing. Mg2 plus, there are Cl minus. Obviously, this side got another Cl minus, which I don't want to care. And then the key thing is there are what? There are water. How many? Not one, but 6 water molecule. They will do ion dipole interaction with it. So it do how many times? It do 6 times. Okay. Am I okay? That's it. And 6 water molecules, all right, surround it. Once again, this blue color is your ion dipole interaction. And therefore, you break the electrostatic force of attraction. Now, chloride, why don't we also put 6 water over there, right? Nothing wrong, you can put, but the thing is the chloride there doesn't affect our pH, so we don't show it. Understand what I'm doing? Make sense? Right? All we want to show is why the pH is 6.5. The chloride there won't affect the pH, right? So we don't show. So this is your hydration equation, 1 mark in exam. Okay, single arrow. Then you have a second step. What's the second step? The second step is here. The second step is known as hydrolysis. Hydrolysis comes from the bio term lysis, means break. Hydro means water is involved. That's it. So if you look at it, what really happened is this. Right? So your current hydrated ion, which is here. Okay, your current ion is here, right? Oh, there are 6 of them. I just draw 3. You don't mind, huh? Okay. Oh, there are total 6. Then what happened is there is a water molecule that come here. Hello, I am water. This is the one. You know that hydrated ion over here, what is it working as? This ion is basically this ion. Make sense? It's acid-base. This acts as an acid. This acts as a base. Okay? Now, ladies and gentlemen, this is what happened. All right? There's a lone pair here. Make sense? Take a look at the reaction mechanism. See what I see? Done. In brown. Okay? This, slowly, is actually diesel. Make sense? And this, a bit overlay to my H3O plus, is this. So once again, there are 2 reactions occurring and that cause it to have a pH equals 6.5. All your ionic salts will get hydrated based on strong ion dipole interaction with nearby water molecules. After which, the hydrated ions, the one in pink, will then undergo hydrolysis with an adjacent, a nearby water molecule with acid-base reaction, where it produces H3O plus. And your pH is 6.5. Why isn't it higher but just 6.5? Simply because, all right, it's a reversible reaction. So it might reverse back. So the H plus that come out won't be a lot. So you get only a slightly acidic solution. Now, why once again is only like that? Why only slight hydrolysis? Why only slight? Why reversible? Simply because magnesium, yes, it has a higher charge density, but it's still not too high compared to the next one. So it's still not very high. So the polarizing power by the Mg2 plus is not very strong. Oh, so the whole idea is the Mg2 plus keep pulling this bond. Can you see now? Pull until that bond break. Am I okay? Oh, it distorts the bond here. Can you see now? Then the bond in the water that's attached to it break. Yes, then it's transferred to the adjacent orange colored water molecule. Okay? Hydration, hydrolysis. If you would like to catch my latest videos, click on subscribe button right now. And click on the bell if you want to receive instant notifications once I've uploaded my latest video.
If you'd like to join my live chemistry classes and revision workshops, go on to winnerseducation.com and find out how you can score distinction for chemistry on a consistent basis, either in our center or online via Zoom. If you want to check out my online school, go on to passwithdistinction.teachable.com. You'll be able to learn chemistry concepts at your own pace and anywhere in the world, topic by topic. This is Sean Chua from Winners Education, to your distinction in chemistry.